Welcome to Symbol Tech Working Bench. Welcome back, guys. So today's video is gonna be about the last project that I was working in, and I posted in some Facebook groups regarding my how to make your own soldering station. And looks like I get few subscribers, so looks like the people are interested to learn how to do it. So in this video I'm gonna cover all the components that we need. I'm gonna cover the schematic. I'm gonna cover also the code that I write for, and I'm gonna also attach the files that you can download from the description below. So let's start with all the components that we need first. So first we need a STM32 because it's faster than Arduino. So the code first I write it for Arduino Nano, Arduino Uno, and then I say let me increment the code also for STM and to compare which one is faster. So definitely this is faster. Definitely also it's very cheap, costing same like a Arduino Nano board. So I also suggest for these projects to use a STM32. It's very easy to program and it's more powerful than Arduino. So we need this STM32. Then we need the OLED display communication with the 4 pin only. That is very easy and you don't need to hook up too many pins to the STM. Then we need an IR sensor. This one also is very cheap. Then we need 3 push button. That one it will gonna be to lower the temperature, one to increase the temperature, and then the third one, once you set up the temperature that you like, just press setup and it will gonna start to hit on that desired temperature. We need also an LM358 open IC. Then we need a MOSFET. I use this board because it's easy to buy it, and I was tinkering with more things like controlling motors and stuff like that that any single MOSFET like that can do. Ideally use IRF 1010. Let me focus to see the name. So if you can see, it's IRF 1010. Then we need a USB adapter for the STM. If you use a Nano, you don't need this one, but this one is for STM in order to program the program inside the STM, because I'm using Arduino IDE environment. Then we need one N4007 diode that is gonna goes on the gate of the MOSFET. Then we need a ceramic capacitor 100 nanofarads, so if you can see it's 104. We need 1K1 resistor. We need 100K1 resistor, and another another 4 resistors that are 10K. 3 we need for the pushy button to put the pull-up resistors, and 1 we need for the LM358. Then you need a voltage regulator. I use L7805 with 2 capacitors next to it. One is 33 microfarad and then 10 microfarad. And I already hook up in this road, so I have 24 volts in, ground, and 5 volts out from this LM. Make sure that you are putting on a good heatsink because it's coming a bit warm, because it's working hard from 24 volts to reduce to 5 volts. Then we need the breadboard for the trial, where I'm gonna hook up all the stuff, and some jumper wires here. And the last one, what we need, is important for the soldering iron, the soldering iron handle. So this one is the one that use 936 stations, has this 5-pin connector, and where 1 and 2 is the heating, 3 it will gonna goes to earth, and then I have 1 and 2, no, 4 and 5 that are the thermistor. And then we're gonna start to build it on a breadboard and give a test. Compare also with my one that I have here, that is with the T12, and then comparing to see how this perform when, for example, you need to desolder a very big part like that, and how my it will gonna perform with the same temperature, to see which one is the best, this one or the one that I'm building. So let's go to my computer right now. Okay, so here we have the schematic diagram for STM32. So you can see here we have the LM358 that will gonna be connected to this 3 resistor and capacitor, how I mentioned before. So 100K resistor from the pin number 1 to pin number 2, and from pin number 2 1K resistor to ground. The black line here is all ground. Then pin number 3 10K resistor with 100 nanofarad capacitor to ground, and from that resistor we're gonna read the sensor from the tip, is the pin 5 and number 4 and 5 the sensor. Then we have pin number 1 that also goes to A0 to the STM32. Then we have the 24 volts that coming in goes to the heating element pin 1 and 2 from the GX16 plug with 5 pins. So 24 volts pass through the heating element and goes to the MOSFET, and when the MOSFET is closed, the heating is cold, and when the MOSFET get open from the gate, it will gonna goes to get hot. 1K resistor from the gate to ground again, and a diode 1N4007 from the pin number A8 from STM goes to the MOSFET. Then we have 24 volts coming into the 7805 IC voltage regulator with the 2 capacitor 33 microfarads from the pin number 1 to ground, and from pin number 3 to ground again 10 microfarads capacitor. Also here I use a diode just to direct the voltage only to go out to supply the power for the LM358, for the OLED display, and for the STM32. So we can see is go to VCC to the sensor, also IR sensor is go to VCC to the OLED display, and the red color goes also to pin number 8, which is positive, and then for pin number 4 goes to ground. Then we have the pushy buttons here that I say they go to ground and pull up resistor to positive, and from set down button goes to pin number A11 to STM32. From set goes to A15, and from step up go to A12. Then we have SCL and SDA from the OLED display. That goes SCL is this light blue, goes to the B6, SDA go to the B7. ER sensor signal goes to B4. So this is the schematic, very easy. Now I'm going to show also the one for Arduino if someone wants to use an Arduino. So for Arduino it's the same, all the connections here are exactly the same, just from Arduino it will gonna change different to the OLED display, sensor and buttons. So from A0, from Arduino analog 0 goes to goes to the pin number 1 to LM358. Then we have here the pushy buttons that step down, go to D8, set, go to D4, step up, go to D7. Then SCL, it will gonna go to A5 and SDA to A4, and the MOSFET gate, it will gonna be connected to D3. Now let's have a look also a bit in the code and to tell you which library you need to use for this this project. So this is the code that is for STM32. So here also I mentioned how to connect the pins, and also I put some comments where you can see that are the pins connected. So see here in sensor, PA0 goes to LM358 and so on. So the library that you need to install in your Arduino IDE is spi.h, wire.h, Adafruit gfx.h, Adafruit ssd 1306/_STM32.h. So you're gonna use that library for this. Make sure that you download from GitHub to run this program, and here is all right the program to work on your STM32. Let's have a look also a bit on the code that run for Arduino. The same, you're gonna need the same libraries. So you need SPI, Y, Adafruit SSD 1306.h for the display, and here also the same. I write down the comments how to connect the pins. So I'm gonna make available the schematic and the codes on the description below in this video. Now let's go back to my bench and give some test to this this project. Back to my bench. I also draw the schematic on my notebook here in order to have in front of me when I'm gonna hook up everything. So I'm gonna go in speedy mode once I'm gonna hook up everything, and we're gonna give a try. Now we need to take our FTDI serial adapter and connect some wires. So we're going to use the black for ground, which is the first pin. I'm gonna use the positive for the orange one, which is the third pin over here. I'm gonna use the blue one for, let's have a look, what's the first pin? The first pin is the TX, and the green one for RX. And we need to hook up with the board in order to program the STM32. So we're gonna come ground to ground, positive to positive, and be sure that this jumper here you put it in 5 volts, because I have 3.3 volts and 5 volts, so this one we need the 5 volts, so I set up to 5 volts. Then first I say that is the TX goes to A10, which is this one, A10, and RX goes to A9, which is the A9 over here. Now let's go to my computer, prepare the Arduino IDE and upload the sketch into. At this point, after I hook up the the FTDI serial adapter to STM32, we need to connect with the computer. So now it's connected to the computer, and now you can see nothing come on the screen. We need to, there is in STM32 you have 2 jumpers here. Just hold it like that. So you have these 2 jumpers over here, the 2 yellow jumpers over here. Let me bring it closer, or better if I zoom. Just let me zoom a bit. Okay, so if you can see, there is these 2 jumpers. So we need to take the first one and move it to the other 2 pins over here, and then to hit the button reset in order to put the STM board in program mode. So now the STM is in program mode. The only thing what you need to do now is to go to our sketch and select the proper board. So you go to board managers and you scroll down, because from the beginning it's gonna shows you just Arduino, so it's gonna be like that. So you scroll down until you find your board, which is this generic STM32 F103 series. So you click on, then you click again Tools, you select the which one you have, because there is 2 models, the 64K flash or 128K flash. So in my model is the 128K flash. Then you go to select the serial, because we are using a serial adapter. Click on serial, and it goes to check the COM port. So this is COM 8, this is COM 10, the scrolling text. So I'm using with the COM port 8. And once you are there, you just need to hit the upload button and let the code come into STM32. So let's wait until my Arduino IDE, it will gonna compile the sketch and it will gonna upload it. So now when it's uploading, then the LEDs are flashing very fast, so you can see those ones there. And now it's telling me that it's done uploading. And now on our display we have the program up and running. So let's go back to my working bench and give a test with soldering. Once we finish the programming, the STM32, we can unplug the FTDI from the computer. We can also disconnect from the STM32. So this one can go out from this situation here. Then what we need is to move the jumper back to the place when it's running the program. Then we need to hook up the power. So as I say, these two, they are gonna be the positive 24 volts, so they will gonna go connected to this red clip. So how gonna do like that? I'm gonna put them here together in one point on this breadboard, and I'm gonna use another wire. Let me wrap a wire around here. I'm gonna just clip this one to the positive. Then, as I said, that this block here, it's gonna be the negative. Let's power on also my multimeter to the voltage. Let's turn on my power bench supply. And let's give the power. So on the power, so it's coming with my message here, as I say. Let's measure to be sure that we have 24 volts over there. So ground and positive here. You can see 24 volts is over there. Grab them good. Yeah, 24 volts and 0.58. Then let's set up on the point that start to melt the solder wire. But first of all, I want to do, as I said, I'm gonna do a test to see how fast is this one getting reaching the temperature that you want to solder, and who is performing better between this one or this one here to desolder to melt a big piece like that where it's full of metal around. So first of all, I'm gonna measure the tip to be sure that I'm using the same size of tip. So let's have a look. This is telling me that is 1.4. Yeah, 1.4. And let's have a look at this one that is here. 1.5, so are the same. So good that I can make a comparison with the same size of the tip. And let's set up, as I say. So I say I'm gonna set up like 220 degrees, because like there is the temperature that start to melt the solder wire. I'm gonna get the solder wire here. I'm gonna prepare also the timer, and let's see how long it needs to get from the normal temperature that is now like 26 degrees like that in the room. And let's go to timer, and let's press start in the same times. Yeah, start the point. So as I say, like 36 seconds, and we are already in the time that we can melt good the solder wire. Let's stop this this one. Okay, I'm gonna power off from here also. So as I say in mine, get on the time of soldering good in 36 seconds. And now let's bring this one a bit more here. And let's start in the same time. And let's see. So twice faster. It's already getting in 13 seconds on the temperature of 220 degrees, as you can see it here. Yeah, it's quite faster. To get the temperature is quite faster. Let's now make the test about what I say, to see how can handle to melt a big piece like that. So I'm gonna start first with mine. So 0 here, turn on the power back. Okay, let's set up to 250 degrees like that. Let's start. And let's wait to get the iron already hot. So gonna appear anyway here on the screen when it's ready. So it's telling me that it's ready, so let's try to see how that performs on melting with this small tip of very big. So wait a bit, we're gonna also, no, we don't need the time. So let's see how it will gonna manage, how many degrees it needs to melt a big piece like that. So I can see start melting but struggling. But anyway, in 250 degrees still managed to melt a bit. Let's increase the temperature here, go up to 280 degrees. Let's set up 280 degrees. Let's have a look what it's doing in 280 degrees. And in 280 degrees, how you can see, it's melting very nice. Look, I can melt all these big, both of them. Look, let's turn off this. So this one melting good on 280 degrees. Set up the station. And now let's have a look how that performs in 280 degrees. Let's turn on. And let's set up 280 degrees. Here we are in 280 degrees. So now it's reached the temperature. Let's see how it's melting this one. So you can see it doesn't have power enough at all. Doesn't melt. 280 degrees and doesn't melt at all. So we need to increase. Let's see how many degrees I need to increase. So let's go up to 330 degrees. Let's see 330 degrees what it's doing. Still nothing. Let's increase more. We need to go to 380 degrees. So now it's 380 degrees. Let's have a look. 380 degrees. So at 380 degrees, just little that it's melting. So in order to melt with the same like the other one, I think I need to go up to 400 degrees. Let's go to 400 degrees. 400 degrees, let's see. 400 degrees. Yeah, I can say that I can melt a big part like that. So this one can be slower to reach the temperature, but then working better on soldering with that. So I just put on this breadboard the Arduino Nano to make a demonstration that is working good also with Arduino Nano. So let's grow up the temperature to 220 degrees and let's see how many seconds is slower than the STM. So I'm gonna open here the stopwatch. So let's put them there. Let's play in the same times, play in this one, and let's have a look. How long need to get that temperature to melt. So you can see it was 36 with STM, and with Arduino it's 40 seconds. So yeah, it's slightly slower than STM32. Also the graphic, it's not that much nicer like the STM. Arduino doesn't have that capability to handle the graphic nicer like STM. Then I'm gonna swap now back to the STM on the breadboard, and I'm gonna give a quick demonstration also how the sensor work. I zoom also in a bit to see better the screen. So let's give power. So when it's starting with this message, and then it's telling me that it's cold. Yeah, you can see it's cold. Then let's see the timing of the standby. So I'm gonna prepare again my time swatch. So when I get there, I'm gonna press play. Okay, so let's have a look. As I mentioned, I set up like 3 minutes over the standby when the iron tip is staying up to 120 degrees. If you find this temperature too much low in the code, very easy, you can find that one and you can modify. You can make it up to 150 degrees or 160, 80, how you like. That one is easy to modify in the code. Just read the comments of the code, because I'm gonna put also comments to the lines where you can modify the code if you like to be in different way to work for you. And if you think that this time is long, also this one easy from the code, you can modify the time. I'm gonna also put their comments where you need to modify the numbers to make longer or shorter this standby period until the soldering station goes in switch off mode. So I can see it's 2 minutes and 46 seconds. And now the soldering station is switched off properly, the MOSFET. The iron, it will gonna get properly cool, and you can leave it like that. It will not happen nothing. And once you come back, just take the handle and the iron start. And let's see also another quick demonstration. If I set up the iron, let's see, 240 degrees, let's say. And I can see the temperature growing up. It's telling me the percentual how it's opening the MOSFET. The MOSFET now is open at 100%. And is drawing a current of 1.5 amp for the heating element. Once reach the temperature, it will gonna appear also on the screen ready. That see now is ready, that you can now use the iron. So yeah, this was the content. I hope that you learn how to make this soldering station, and I hope that you don't get bored. And yeah, what I wanted to demonstrate again, just we need again to wait that 2 minutes and 40 seconds to show something, because when it's going in standby, you're gonna see that the temperature is gonna drop to 120 degrees. But then when you come back, you don't need again to set up the temperature. Once you take the iron from the handle, no, from the holder, it's gonna go straight away to the temperature that you used it last time. So let me show also that demonstration. I also designed already the PCB board for this one. I'm gonna order it through GLC PCB, and I'm gonna need to wait like 2 weeks to receive, and then to start to solder everything in place and to see a nice case. And I'm still waiting for the male plug for this GX16 connector, because the handle come only with that one, doesn't have a male. So I'm waiting for the male to arrive to receive it, in order that to build my own proper soldering station. Okay, so see, now it goes in off mode. Let's leave a bit to get also more cooled, because I say now it's still 110 degrees and it's getting cooler and cooler until it's getting the normal ambient room temperature. So let's wait a bit, then I'm gonna just take it from that place and you're gonna see how it goes straight away to the temperature that was set at before. So was set up in 240 degrees, right? So we're gonna see that 240 degrees setup already here. Only this one gets a bit hot, as I say, that's why. Please make sure that this one, it's gonna have enough heat sink in order to dissipate the heat, because it's working hard from 24 volts to get down to the 5 volts that you need to supply to all these devices. Let's see how hot it is. Still hot. Well, so let's go out from there. See, 240 degrees. So it's all gonna go back now to 240 degrees. We have to start again to set up the temperature. I hope you enjoyed this video. I hope now you learn how to make your own soldering station iron. So schematic diagram plus codes you're gonna find in descriptions, so please download from there. And if you might face any problem and it's not working, please let me know which problem you face. I'm gonna try to help you to make it work. As I say, if you want to use a Nano, it's working also with the Nano. Use the code that I write for Nano. But as I mentioned, it will gonna be a bit more slower. And if you have STM32, use STM32 and use the code that I write for STM32. So the code that I write for STM32 is with Arduino IDE environment, and you're not gonna need a FTDI to serial adapter like that in order to upload the code into STM32. But if you have ST-Link, you're gonna need to use the ST bootloader there when you need to program when you need to upload the program inside the STM. If you like the video, please put a like. Don't forget to subscribe to my channel. Activate the notification bell. I have other few projects coming in soon. And for the moment, I'm gonna say bye bye and see you for the next video.